And this is why a traditional field solver may take hours and hours to solve a simple electromagnetic structure, and a well-trained AI model can just recognize where the fields and waves will be. Just like a well-trained electrical engineer who's been doing RF design for many, many years and has already visualized in their own mind can intuitively understand, oh, this structure here is going to have impedance discontinuity at this frequency, and I know because I'm looking at it and I can see roughly the size of it.
Nice.
That's the difference we're talking about. So we're in a way we're modeling or replicating human intuition. I don't know. I might be way off with that analog, but correct me.
I think it's a great analog. I mean, I think the critical point is you need some way to say, I've seen 1 million simulations. This one looks like something like the average of these three, and these are pretty close. So let me find a point that's kind of like roughly around there and say that's it, right? So like, if you didn't have any training data for the net, it's going to be useless. But if it's seen very similar cases before, then it's likely to predict a roughly accurate result. Mm-hmm. And you shouldn't use that for your ground truth forever, but it's 1,000 times faster. And so you can iterate with it much more quickly and then validate the final result.